what we have here in front of me is the most special machine that I have ever had on this bench, that I have ever had on any bench I worked on. And probably for someone with my background, I'm a computer engineer. I went to computer engineering school. I was 17 years old because at 6 I had fallen in love with microcomputers. I had a ZX81. I was 6 or 7 years old. After that, I had a ZX Spectrum, an Apple II, an MSX, and then the world of PCs. But it was that early experience that brought me, when I was just 17 years old, I had just turned 17, and I went to computer engineering school because of my love for microcomputers. And this, as far as I can ascertain as of this recording, is the very first microcomputer, meaning a fully integrated desktop computer with a microprocessor within, as opposed to a CPU made up of TTL logic. This is the first true microcomputer in the world. It's a Q1 Corporation Q1 machine, and the first versions of these machines had an Intel 8008, I believe, microprocessor. Microprocessor was invented in 1971 by Federico Fagin. So it had one of the very first microprocessors. The very first was a 4004, which went into a calculator. You can read Federico's book, Silicon, which retells the story of all that. But this may be, and is, insofar as I can ascertain, the first desktop machine to use a fully integrated microprocessor as its CPU.
A little intermezzo here. As far as I know, this document that you see now is the only thing available online about the Q1 system. It's an entry on ode-computers.com, which is referenced to Daniel Alroy and the website phylon.net. And now that website no longer exists, so the original reference is lost. All we have is this text. And as you can see there, the Q1 was the first microcomputer. It utilized an Intel 8008. Now the 8008 had been commissioned by Computer Terminal Corporation, CTC, the makers of the Datapoint terminals, and it had been commissioned for the Datapoint 2200, which was supposed to be an intelligent terminal, but Intel didn't deliver it on time, so Datapoint ended up using normal TTL logic to implement their byte-oriented CPU, and the Datapoint 2200 was likely the first fully integrated desktop computer, but it initially didn't use a microprocessor, so it was not a microcomputer. And according to this entry here, the Q1 was the first microcomputer. It introduced its first system in December of 1972 and a second one in February of 73. So that would make it the very first fully integrated computer to use a microprocessor. In other words, the very first microcomputer. And it remained that until later in 1973, according to this entry. Now, later versions of the Q1 started using the Z80 processor, designed again by Federico Fagin, but after he left Intel and founded the Zilog in 1974. So they are still Q1s, they are still members of the Q1 product line, but they no longer used the 8008.
Now, I cannot find any information about the Q1 online other than a later sales brochure, which is available on BitSavers. The links are on the description below. But the picture you have there is of a slightly different machine. It doesn't have this panel that this machine has. And those later machines already used the Z80 microprocessor, also designed by Federico Fagin, but Federico was already at Intel, and those processors came out in 1974, the year I was born. So this one is different. Now, two things could account for the difference. Maybe this is an European model, although I am not aware of Q1 Corporation having made European models. or it could be the actual very, very first Q1 with a 8008 microprocessor. And then this would be not only, the product that was the first true microcomputer, but even the first revision of that product. And for me, this is mind-boggling. It's like my head is going to explode, like, the brains of the aliens in Mars attacks. That's how I feel, because this machine set everything off. It set off my life. This is the first machine of the thing that made me go to computer engineering school at 17 and has set the tone for my entire life. I'm also a philosopher next to being a computer engineer, and that's a bigger part of my life today than technology. I sort of retired from technology 2 years ago. But my character, my history, they have been defined by a love for microcomputers. And the story of how this ended up with me is even nicer and more full of synchronicities, because a trader of retro technology in the Netherlands, a professional trader who buys and sells retro technology, he is the one who found this. And it so happens that the man is a historian by education. So he has the education and he has the heart of a historian. And this for him probably was, the jackpot. But he's a historian and he's responsible and an overall very good person. And he realized that this was not something to throw into the trading game. He understood the historical significance of this thing here. I can hardly believe I'm touching. And he made sure that it would land in responsible hands and that it would have an appropriate final resting place. This machine is going to go to the Dutch Home Computer Museum after I reverse engineer and document it. As for a restoration, I intend to do it, but if the restoration requires defacing this, then I may not do it at all. I may even leave it unrepaired. If there are components here that cannot be found anymore, and to replace them with modern alternatives, I would have to deface it, then I don't think I would do that. I would talk to Bart, who is the director of the Dutch Home Computer Museum, to see how we go about it. But my feeling right now is either I fix it if I can replace things with identical versions of the parts that are defective, or I will not even repair it in order to preserve its original state as much as possible. Now, one thing that is very conspicuous here is how short this is. You see, it's not deep at all. It's very long, like an Amstrad CPC, but the depth is not much at all. And I thought at first that this is a short neck CRT. The screen is here. I don't know whether you can see there. The screen is over here. And I thought this probably is a short neck CRT installed at an angle so it goes down, so it has more room than it seems. But I'm looking at sort of the sheen, the reflections on what appears to be the screen. And the screen seen from here, I'll remove this at some point so we can see better. I will disassemble this and look inside, of course. But at first sight, the screen seems to be very flat, and it has this neon orange sheen or reflection to it that makes me think that this is actually an early plasma display. And this is entirely possible. The first plasma display used in computers or terminals was in the Plato terminal prototype, which I believe was a university prototype, not a commercial product. It was called the Plato terminal, and it had an orange plasma screen. That was the first instance of a plasma screen in a computer or a terminal, and that was 1964. And this is at the earliest December 1972. So it's entirely possible that this actually has a plasma screen. Plasma screens were not favored from the mid-70s onwards because memory became cheap enough that you could use just a CRT and memory mapped screens instead of a plasma display. A plasma display, for the Plato in dollars of the time, I think it cost like over $2,000, maybe $3,000. And they were rugged, they were robust, resilient, and didn't require refreshing circuitry. So it was economically a good idea in the enterprise sector if you were selling to businesses as opposed to home computers, for individuals, because the price tag of these machines was pretty high. So it made sense to use a plasma display. So right now, looking from here, I'm almost sure this is a plasma display. And it may be working still. Hopefully it is working. If it's not, we can replace with an LCD, but then, would I do that? Would I deface this machine? I don't think I would. I think I would leave a non-working plasma display here. What I have to do under any circumstances is to reverse engineer and document it, because there's nothing online. There's just nothing online about the Q1 beyond the sales brochure on BitSavers, which has no technical details. So that I will do in any case, whether I will repair and restore beyond the cosmetic restoration and safety things like replacing the capacitors to prevent them from leaking later on. It's still to be decided whether I will do that. So let's go ahead and open it up and see what we actually have in our hands.
Before we do that, though, here's a short slide set of the gorgeous looks of this unique machine. It looks so much more advanced than the 70s. It's gorgeous, and the fact that it doesn't have much depth is reminiscent of modern flat panel displays. It has two parallel ports and one serial, and this very strange power connector that you see in there. And a relatively low serial number, 379. That's a good sign, bodes well for the future. Now, open it up is not trivial. Those two top screws that you see me remove right now, yeah, they should be removed. But the bottom two that I'm removing now, they shouldn't, because otherwise the heavy power supply board will become loose. I was paying attention, so I discovered it in time. I felt it, so I'm putting those screws back. It has to be unscrewed, unfortunately, from the bottom. You have to remove some key screws at the bottom. You have to pay attention because otherwise things fall inside. But then you can open it, and once you open it, there are lots of cables going across the two halves. So, you have to remove those cables very carefully one by one before you can actually separate the two sides of the thing and then safely examine the machine.
Okay, right off the bat, this is a Z80 processor. So this is not the earliest Q1. The Z80 processor here has a date code of the 7th week of 78. So unfortunately, this is a much later machine. It is the model that was the first microcomputer, but this particular unit was produced later. 78 date code Z80. The other chips all have 77, late 77 date codes. 77 week 49, 49, week 52 at the very end of 77. And the Z80 is week 7 of 78. The memories are 4160s. So this is an early 1978 machine. Definitely still a very special very unique machine. I haven't seen any data online about it. So this is still very worthy of reverse engineering and finding a place in the museum for it, an honor place in the museum for it. But the trader who sold it to me didn't miss out on the jackpot. Probably can get today several $1,000s for this machine, given the rarity. Well, it's beyond rare. It's unique. I don't know of any other available in any museum, anywhere. There are no photos, nothing, no documentation. But it is not a 1972 or early 73 machine. It is the early, how to say it, it is a Q1, and the Q1 was released in 72. But this particular unit is a later model in which they already moved to the Z80 instead of the earlier Intel processors, and it was produced in early 78. The board seems very typical. CPU, DRAM, the ROMs are here. It seems to be very high quality. The sockets are all precision sockets. They seem to be gold-plated precision sockets. And then a lot of 74 logic. This is reminiscent of the Apple I. 2 chips, deep ICs of 8 pins each, and they are next to each other, so it looks like a 16-pin IC cut in the middle, but it's just 2 ICs. The rest is very typical, pretty high quality, but typical. The screen is indeed a plasma screen.
And what a gorgeous screen it is. Just check that out. It's like pixie tubes in a panel. I'm looking forward to seeing it on and glowing if it works.
There is no CRT in there. There is an analog board, another digital board here. I don't know whether you can see, there's a digital board here, and then an analog board here, and the plasma panel itself is right here. So there is no CRT, there is no NAC. This is indeed a plasma screen. Power supply circuit. A transformer, a fan. This is a filter, a line filter. There is a switch here that's broken, and this is the on-off switch right here. So a unique machine. I will treat it with a lot of care. I will reverse engineer it because there is nothing available online for it. There's no point in reverse engineering the better known machines because we have the schematics. There's a lot of hobbyist information and knowledge available online. So there's nothing to reverse engineer. The work has been done. But this one, there's nothing. And I might even, after reverse engineering this, I might even make a modern clone, because this is all standard 74 logic, LS74, LS08, LS00. This is a 75152, that's less standard, but most of it is standard stuff. I have to check what these are. These are very old ICs, but I should be able to design a modern equivalent for this. That's the I/O controller, I think. And maybe team up with someone to even design a 3D printed case in the same aspect ratio, the same format, maybe a little smaller, doesn't need to be this big, but the same idea, just a shrunk version with an LCD panel instead of the plasma screen. I would dump the ROMs. They are nowhere else. This should be 2708 Yeah, these are 2708. So these are easy to read out with my EEPROM programmers and readers, I hope. I shouldn't have any problem reading them out. Otherwise, I just make a little Arduino circuit and a breadboard, and I provide the necessary voltages, and I will read them out. I'll dump them. I will start a GitHub repository for this machine where I will dump all the material. So ultimately, I hope to have all the ROMs dumped, all the schematics in there, a good understanding of how this works, and then make a modern version for it. That would be pretty cool. That's a very nice project to bring this back into our computing consciousness, because nobody talks about this machine. It's forgotten, and it was the first. I mean, the Q1 was the first, not this Q1, but the Q1 was the first. So this is a representative of the family that was the very first microcomputer. How come we've forgotten about it? We even know that the Datapoint 2200, which was sold as an intelligent terminal, we know it was a microcomputer on the inside. We even know that, so why don't we know about this that was sold as a microcomputer, as a fully integrated desktop microcomputer? We should know more. We don't have any software for it as far as I know, but based on a Z80, it shouldn't be a problem at all to port CPM for it. I mean, somebody ported CPM to Argon, which is based on an EZ80 CPU, like in a couple of days. A colleague of ours from Belgium, Koen ported it in a couple of days for Argon. So I don't expect it to be hard to port CPM for this once we make a modern version of it. And then we have all the CPM applications. That would be gorgeous. And given that it's a plasma display here, an LCD screen would have the same aspect ratio. We can drive it with orange color, so it really looks like, that neon orange glow of old plasma displays, and a case that looks the same. That would be very cool, extremely cool. So that's what I'm gonna do. It would take months to reverse engineer this because I have other projects and I have a day job as well, which then takes most of my time. So I will slowly trace this out, turn out the connections, follow the traces on the main board, and reverse engineer. This is the main board. I have to figure out what this logic board here is. Must have to do. It says there, keyboard display interface. Indeed, this connects. Yeah, this is the keyboard. The display is in there. Maybe this is the keyboard controller. I don't know. Seems to be, because it reads the matrix here and then it goes through this connector over there. It's a lot of logic just for a keyboard display interface, but that's what it appears to be. So I have to reverse engineer that one too, but that shouldn't be much of a problem. And maybe get this one up and running, working. I don't see anything fundamentally impossible to replace here except the plasma display. If that one is bummed, I mean, this is not a very early machine, but it is still exquisitely rare. It's the only unit I know of. It's the only survivor I know of. I don't know of anyone else, anywhere, in any museum, on any internet site, that has a Q1. So yeah, I don't know whether I should replace the plasma display or not if it's busted. Of course, if it's working, then it's fantastic, because the question disappears. And we have the original plasma glow of the display, which is a unique thing. It's a unique experience. Replace this switch, but that's a standard switch. And then measure the semiconductors, clean it out, test the memories, replace what needs to be. I mean, there are many chips here that are no longer manufactured, but they are available, new old stock, from Hong Kong, from eBay, from AliExpress, although those are very doubtful. But there is nothing here that should be impossible to replace, except the plasma display. Even that, maybe we find some on eBay. I don't know. So I'm not that nervous anymore because it's not the first machine, but it is still a literally unique machine in the sense that it's the only known one to have survived. It's the only Q1 that I know of. So I will still treat it with a lot of care, a little less paranoia, a little less nervousness than I was before. So in a sense, it's good for me. For my emotional state, it's good. I feel less responsibility, and this will be a lot of fun to reverse engineer this thing and build a new version. The circuitry, I can make it smaller, although I try to stick. Maybe you should even make the case the same size. Maybe you should do everything the same size and have an identical modern version of the Q1, so people have an idea of exactly what it was. And I now try to reproduce the motherboard as much as possible, exactly like this. I mean, not the DRAMs. I will replace that with one chip, one SRAM. Probably the refresh circuitry will go away. The ROMs will be replaced by one EEPROM. So it will get smaller here and here, maybe around here, but smaller in terms of the number of components. But I can preserve the size and the distribution of the components exactly as it is. Power supply would probably use just a mean well switch mode power supply, which is safer, less heavy, no big transformer like this. But we can preserve, the whole distribution of components and preserve the design identical to what it is as much as possible. That would be pretty cool, and then still have this one working. So that's the project. I'll let you know of the progress. It will be slow progress. I'm still doing Talos, and we still didn't even release Argon Light. When Argon Light is released, when Dean Belfield or L Breaking 2 program, for those on Twitter, when he finishes the firmware, which is very close to the end, we will formally release it, and then there will be a lot of investment of time in there to make demonstration videos, send demonstration boards to magazines and YouTubers, write about it, and promote the thing. And then I'm still doing Talos, and I don't like to start too many different projects before finishing a number of them. So this one will be on the back burner. I will photograph everything immediately before I close this machine now. I will upload all the photos online, so at least there is one repository. It will be on my GitHub repository. There will be a subdirectory dedicated to Q1. There will be a page on thebyteattic.com dedicated to the Q1. You can look at the top menu. There will be a page there called Q1, and I will link to the repository, to the photos. I will write down whatever I know about this machine and its history. I will link to the sales brochure available on BitSavers. So we will have the initial information all online, and then the reverse engineering itself, and then the restoration, that will be in the back burner. I will do that slowly, with a lot of patience, one step at a time. Keep you all updated, but don't expect something immediately. Yeah, that's it from me for now. I'll make the pictures now, close it up, and you should find everything online. The links should be on the description by the time you're watching this. And then next time I will go back to Talos, because we will be working now on the addressing logic card of Talos, the modern RISC mini computer, which will be a lot bigger than this, many more chips than this. Anyway, thanks for watching, take care, and I'll see you next time.